So we're ready for the second part of this mechanism of hydrohalogenation, and unfortunately this document camera keeps cutting off and only recording a certain amount of a video, so it will be a little choppy, and bear with me. I'm not set up with good editing software to make this all professional-like, but we'll try to do the best we can. So last time I had talked about hydrohalogenation and how protonation of propene can give you one of two different carbocations, and in a large mixture of lots of molecules of propene, you'll get some primary carbocation and some secondary carbocation. And then these will be set up to do the addition reaction of the halide to complete the product formation. So as I mentioned before, if the hydrogen from the acid adds to the primary carbon, then you'll get a secondary carbocation. If the hydrogen from the acid attaches to the secondary carbon, then you'll get a primary carbocation. And since the primary carbocation is much less stable, this is going to be the minor intermediate, and you're going to get less of that. Whereas the secondary carbocation is more stable, so that'll be your major intermediate, and you'll get more of that. And what you also had present in the reaction mixture is the halogen. In this case we used hydroiodic acid, so you'll have some iodine present. Regardless of which carbocation is formed, one of the byproducts of the first step is the iodide. And now hopefully you can see that the carbocation and the anion will be attracted to each other fairly significantly. If something's negatively charged and has a lone pair of electrons, it is very often what we call a nucleophile, because it loves positive charges or nuclei. So the nucleophile is negatively charged, typically, definitely has some available electrons, and it's going to be looking for positive charge. The positive charge, the carbocation here, which is positively charged, plus it has an unfilled octet at the carbocation site, so this is very much looking for electrons. That's why it's an electrophile, because it loves electrons. So these two having a natural affinity, then the nucleophile is going to attack, as they call it, the carbocation, and this lone pair of electrons is going to become a bonding pair of electrons. And so that would form the bond, and now you can see the completion of the addition, because whereas the hydrogen added to one carbon in the propene, the iodine adds to the other carbon. So that where there was originally a double bond, now we've added in two new substituents on there, and this would be the 1-iodo-propane. So now we have all single bonds. It takes the "ane" ending instead of the "ene" ending, and on the end carbon, the first carbon, there's an iodine. So 1-iodo-propane, and since we get less of the primary carbocation, we will then get less of the primary iodide. So this will be the minor product, and we'll get less of that. If we go do the same thing but with the secondary carbocation, now we'll have the iodide nucleophile attacking the carbocation electrophile to create an iodine carbon bond. Then again, you'll see how the addition reaction is now complete because we've added the hydrogen and the iodide, the hydrohalogenation. And in this case, though, we would get the 2-iodo-propane, where the iodine attaches to the secondary carbon, and that's favored. This will be the major product, because the secondary carbocation was more stable, so we get more of that. So that would wrap up the mechanism, and we would get more 2-iodo-propane and less 1-iodo-propane, but both would be products of this reaction. So if you have propene plus hydroiodic acid, you will get a mixture of products, the 1-iodopropane and the 2-iodopropane, and understanding both what we will get and which product is going to be the major product comes from a complete understanding of the mechanism. So definitely a good idea to work through relatively simple two-step mechanism, protonation of the alkene to give a carbocation intermediate. Then the second step is the nucleophilic attack of the halogen on the carbocation to give the final product. So hopefully this is clear and useful and will prepare you well for the final exam.